One was with a ladder.
Probably a triangle then, if it was a ladder?
The top of the 15-foot ladder is 3 feet farther up the wall than the foot of the ladder is from the bottom of the wall. How far is the foot of the ladder from the bottom of the wall?
So from that statement already, that's what I would write. The ladder is leaning against the wall and it's 15 feet long. That's the hypotenuse. The top of the wall, the top of the ladder is 3 feet further than the bottom is from the bottom of the wall. So call the bottom of the bottom length of the triangle. So this is where this is where the wall is right here. This is the floor right down here. Okay, so this point right here, the bottom of the ladder is some distance from the base of or from the wall. Well, this height is 3 more than what you were told for the base. So that's what I would start with for a diagram. What would I do next? I mean, you haven't taken geometry yet, but do you remember what you would do next? Has anyone, you've used this theorem before, I'm assuming, Morgan? Yeah, go ahead and use Pythagorean theorem. You have a squared plus quantity b squared equals c squared. Okay, and it looks like, it might be a little bit of work, but all you got to do is solve, all right? You're going to have to FOIL that out. You're going to have to move the 15 squared, which is 225, over to the left. Get everything equal to 0, and then refactor. It's not in factored form. This is something I want to point out, actually. It's good that you asked this then. Take a look here. I've seen this in the past on other tests. A lot of students tell me x equals negative 3 is the answer to this. They stop here and x equals negative 3 and x equals 0. First of all, there's a plus sign, so it's not factored, right? There's 2 terms being added. It's not factored. And secondly, it's not equal to 0. So please don't look at this and just give me an answer right away. It's got to be equal to 0. You can absolutely 100% expect a question on tomorrow's test where you have something that looks like it's factored, and then on the other side there's a number. And in that case, you cannot just look at the factors and solve. You need to FOIL that out, and then move the number that's over to get 0, then refactor. And that's literally what we're doing here. Is that clear? So even if this were multiplied, so even if it were this, I'm just giving you a hypothetical. This might not work out number-wise. This is a hypothetical. If I had something like this, you cannot solve that. You can't just say negative 4 and positive 3 because there's not a 0 on the other side, and only the zero product property allows me to look at each factor as the value of 0 and solve with that t-chart. Because there's no 0 over there, you can't. So you have to FOIL it out. It's definitely not going to work, actually. Oh, whatever. Well, maybe it would. I don't know. Well, this is what you're going to get when you FOIL it out, right? And then you have to move the 12 over, so it becomes negative 24. So if you're solving something like this, you can definitely expect to move things over and then factor what's in that box right there. I don't think that factors. That's what I was saying. Nothing multiplies to 24 that adds up to 1, right? 24 is 2 and 12, 6 and 4, 3 and 8. None of those combinations are going to give you 1 in the middle. So this one is not factorable, but do you understand what I'm getting at? The process involved? It's the same thing we have here. So let's take a look at this. We've got x squared. X plus 3, x plus 3. You have to FOIL. It is not x squared plus 9. You cannot distribute the square term. There's a plus in the middle, right? You have a sum here. If this were 3 times x, you could make it 9 times x squared, but this is x plus 3. So FOIL it out, x plus 3, x plus 3. And by now you should know that the middle term is always the sum of those two. So we have a 6x plus a 9 equals 225. Okay? Can I leave it from there, James? All right. Move the 225 over. Go through the process. I mean, it's going to be AC method, by the way. So, I mean, I guess it's not a bad example to go over because we're going to do AC method on the test. So this is going to be really messy, isn't it? So we're going to have negative 216, I guess. Did anyone solve this if they look at their problem set? What did you end up getting when you factored this? Did anyone get it? No? What do you got, Chandler?
I factored out 2.
Oh, smart, obviously.
And then I got 2x minus 9, and then multiplied by x plus 12 equals 0.
X minus 9, x plus 12. Yeah. And I clearly had a brain fart, okay? Don't do what I just did there. What was that? I was about to use AC method which would be a real mess, because AC method would give me, what, 2 times 216, I'm going to have to deal with like 432. I have to list the factors of 432. So definitely look for a GCF. Okay, definitely look for a GCF. These two numbers multiply with negative 108 and add up to positive 3 in the middle. Okay, so positive 9 and negative 12. Which is the real answer? Which is the real answer? Positive 9 or negative 12? Yeah, why? Yeah, it's a length. A length cannot be negative. Okay? So the base of the triangle is 9. The height up the wall is 12. I don't know what it actually asked you for, which dimension, but you give whichever answer it asked for. Okay? Other questions on the problem set? Yeah, Alex.
The same chapter, but
Mhm.
problem 24.
You want to read it? Go ahead.
Do 21 meter of fencing to enclose a rectangular pen having area of 55 meters squared. Only 3 sides of the pen need fencing because part of an existing wall will form the 4th side. Find the dimensions of the pen.
So that's what I'm seeing right away, right? The first thing I think about is, how do I draw a diagram for this? Whenever you have something with geometry, draw yourself a diagram, please. So we have a garden or a pen or whatever you want to call it, and one of the sides is adjacent to the house, so as a result, we don't need 4 sides, we only need 3. What if I had told you, and this is just hypothetical, how does this problem change? Or let's start the problem first, then I'll ask that toward the end. So if I want to go ahead and figure out what the dimensions are for this, what would I do? How would I begin a problem like this? How would I begin this? What statements can I write? Is it just me or is it a little bit more up here? No? What do you think? How do I start this? Did anybody get this? Nobody got it? Did it give you any other information at all about the length and width? Nothing else about the relationship between the length and width?
No.
Okay, Morgan?
I think 2 equations.
Okay, start with 2 equations for sure. What do you got?
I did x, y equals 55, and then 2x plus y is 21.
Where's the second equation come from, Morgan?
The fencing is 21, and there's only 3 sides, and there's 2 x's, so there's 2 widths or lengths. There's only 1 width.
Good. So it doesn't really matter if you call it L or W, just call them X and Y. There are 2 of these lengths, X, so she wrote 2X, plus this 1 Y gives you the overall perimeter, which is 21 meters. The actual area is X times Y, which is 55. So that's all this is, 2 equations. I'm telling you now, you have to be able to solve something like this, where you have 2 equations and using substitution method. So what is your next step? We did this in class at this point. What is your next step to solve this, James?
You need y by itself in the second equation.
Okay, and then take that and do what with it? Good. Okay, that's why we're calling it substitution method. So this becomes x times the quantity 21 minus 2x, which is really just y, and that equals 55. That's going to be our governing equation at the bottom there. Okay, again, substitution method tells us we can substitute a value that's equivalent to another variable into that variable, so we get this bottom equation. And now, again, we just have to go ahead and distribute and solve. Okay, distribute and solve. So we're going to have 21x minus 2x squared minus 55 equals 0. I should put it in the correct order. Here's an example where we do have to use AC method, though. Now, before I go further, can somebody recommend I do something to make life a whole lot easier on myself? Sarah? Yeah, multiply everything by negative 1. Because I want 2x squared to be positive. I don't want it to be negative. So negate or switch all the signs and make sure these are in the correct order. So start by putting 2x squared in the front. But since we make that positive, we have to switch all the other signs. Hence, or as a result, multiplying by negative 1. Okay? And now we're going to have to use AC method, unfortunately, because there is no GCF this time. Let's do that, okay? Because we need to practice this. Some of you are good at it. Others are still making common mistakes or, careless mistakes at times. So on the side, we're going to list AC. 2 times 55 is 110. I'm going to also list B. B is negative 21. Can you please tell me what numbers give you 110 when multiplied and sum up to negative 21, Alex?
Negative 10 and negative 11.
Yeah. Negative 11 and negative 10 add up to negative 21. And they happen to multiply to give you positive 110. So we break up the middle term into those two terms. That's where this 21 comes from. See how I'm drawing this arrow right here to break it up? I can see that that's the sum. So I'm going to break this into negative 11x and negative 10x. It does not matter which order I put them in. The factoring might look different, but it really doesn't matter. You'll get the same answers in the end. So I'm going to go with negative, I don't know, let's go with negative 10x and then negative 11x plus the 55 at the end. M, help me out with this one. We were working on this yesterday. What would I get when I factor this?
You'll get x and then parentheses. I did it the opposite way, so I did negative 11x plus negative 10x. So
Okay, hold on one sec. So you had, that's fine. No, no, that's good because we'll see that it's the same answer no matter what.
so it's x and then in parentheses 2x minus 11.
Good, and over here?
And then it's negative 5 and then in parentheses it's 2x minus 11. So then 2x minus 11 gets carried out to the front and then it's x minus 5.
Very good. Okay, do you all see how that works? So the goal in this process is to break up the four terms into two terms and two terms. It doesn't matter whether the 11 or 10 are in different spots. You get the same factors or just be switched, which is the same thing as multiplication is commutative. So when you factor out x in the front, you're left with this 2x minus 11. Well, the only way you can get 2x minus 11, remember, it has to appear here and here. So once you take out this x and you're left with 2x minus 11, you could already write 2x minus 11. Because you know that has to be there, right? And then think to yourself, what has to come out of here to give me 2x minus 11? And it's not just 5, but it's negative 5. That's really important. Because a lot of people, the mistakes I see is they forget the negative sign and then it looks like these factors are different. So if you get factors that are, or values that are different here and here, you may have forgotten to take out a negative also. Okay? So if I take out the 5, is what gives me 2, so I take out the negative 5. And then you can go ahead and solve. Solving this gives me two solutions. This is going to be x equals 11 over 2, and this is going to be x equals 5. Which is the answer? Which is the answer? 11 over 2 is 5.5, right? So x is either 5.5 or 5. Which one? Why could it be both? Yeah, remember this was a geometric diagram. We're not necessarily saying that x or y are certain values. We were just trying to figure out what they are. So let's go back to our diagram. Here's our diagram. I think it was Morgan, right? Morgan chose x and x for the top ones and y for the side. So if x is 5, this is diagram, or let's do 5, this is 5.5, right here? Let's do 5.5. If x is 5.5, what is y? This is scenario 1 on the left, and then we'll do scenario 2 on the right. What does y become if x is 5.5? Daniela? 10. Remember the area was 55. It's always easier to figure out y from the area formula. 5.5 times 10 gives you 55. And if you sum these, 5.5 is 11, and 10 gives you 21, which is the perimeter. So that's how you check if you're correct. You could always check these problems. On the other hand, though, we could do this. We could say, well, x is 5. If that's the case, what's y? 11. Okay, because 5 times 11 is 55. Both scenarios work. If the problem specified that the dimensions are integers, then obviously the one on the right is your answer. But there's no other way to actually decide which answer is correct and which is not correct. Because the perimeter checks out. 11 plus 5 is 21. Okay? Again, this kind of a problem when you guys take the SAT and your standardized tests, since those are multiple choice, we'll have only one right answer. So it would probably say, find an integer solution for the dimensions of this rectangular pen. Okay? Other questions? So that was 4-8, both of those questions, right? Look at your problem set. See if there was other stuff you were wondering about. 20, you want to look it up?
Yeah, I think it was 26. It's x to the fourth minus 18 is less than 7x squared.
Okay. Inequality, solve it the same way as an equation, but we have to think about critical points. So to solve an equation, though, what do you need on one side? Anybody? 0. So let's move the 7x squared over. And put it in the right order, please. Put the 7x squared in the middle. And this is really no different than a quadratic. Sarah, what do I get when I factor this?
X squared minus 9.
So far, plus 2 you said, right? So far what we're seeing here is that the factoring process is the same except that those are x squareds. Why are they x squareds? Like why isn't one x cubed and one of them x? X cubed times x gives me x to the fourth. I could do that. Right? I mean, we never really went over that. Why isn't it x to the third and x to the first in those factors? Like, why isn't this one here x cubed and this x? Because x cubed times x gives me x to the fourth. Chandler?
Because they won't FOIL out to equal negative 7x squared.
Yeah, when you FOIL it out, you can't have terms that are x cubed or x because the middle term is x squared. So if this were x cubed and you multiply by this 2, you'd get 2x cubed. That doesn't appear anywhere here. So that automatically indicates to you that these have to both be x squareds. Now, I can go further. Remember, factoring is never done until you have it down to its fundamental, or like what we called, what was that? The prime factorization. It's kind of like the prime factorization. This can go further. X squared minus 9. What is that an example of? Anybody remember the name? You might know what the factors are. What is the name of the term that allows me to factor x squared minus 9? What is it called?
Difference of two perfect squares.
Yeah, difference of two perfect squares. So what does that become? X squared minus 9. X squared minus 9. What does it become? If I want to factor it. More?
X minus 3 or x plus 3.
X minus 3 times x plus 3. Very good. That's what x squared minus 9 really is. If that were 16, it'd be x plus 4x minus 4. If there were a coefficient in front of x squared, like 4x squared minus 9, it would be 2x plus 3, 2x minus 3. It's the same process over and over again. Just take the square roots of each term and do a plus and do a minus. Can I factor x squared plus 2? No. So there's no need to do that. Now, I can see why this was a bit confusing, James, now. How do you solve that one, right? That's the problem you're going to have here. This is clearly x equals 3, x equals negative 3. Now, if I set this equal to 0 and solve, that's how we really get our solutions, remember. Here's what I get. What's the square root of negative 2? Can you do that? No, it's not a real answer, we're going to say. We're going to talk about in chapter 6 what we do with that. But for now, we're going to say it's not a real answer or a non-real answer. So there is no real solution for this one. So there's no critical point for this one. Okay, for this portion right here. But you still have 3 and negative 3 as critical points. Okay? No critical points for the part you can't actually get a solution for. And now we're going to test regions. Now where am I going to test it again? Where do I test my points? In what form of the inequality? The factored form. Very good, Will. In the factored form. I'd probably test it right here. Or even up here is fine, actually. It doesn't matter, either one. Okay, but somewhere where it's factored. So let's test 0. If I test 0 up here, it's going to become negative 9 times positive 2. So this is a negative times a positive, which is going to give me a negative region. And by the way, these are open circles here. Then on the outside of 3 and negative 3, I'm going to test 4 and negative 4. So if I test a 4, this is going to be up here. Okay, if I test the 4 up here, it's going to be 16 minus 9, which is positive. Test the 4 here, it's positive. So this answer is going to be positive. Then I choose -4. If I test -4, I'm still squaring it, aren't I? So it's still going to be positive, because this is going to be -4 squared is still 16, positive. -4 squared is still 16, which makes that positive. So we end up with positive regions outside. This polynomial wanted to be less than 0. Numbers that are less than 0 are negative, so I shade which region? Yeah, just the middle region here. Okay, we shade the middle region, and we write our solution set as one of the two following, as interval notation or in set notation. Okay, either solution is acceptable. But you got to write some notation or another, and you have to have it on a number line. Hey, let me show you something real quick. And this is something I was thinking about during the class, and I think we ran out of time. We never got to it. Remember we didn't finish up that last example with this one? Go to your calculators real quick. I'm going to show you a little trick. Make life a whole lot easier on you for these problems to check. I still want to see the work because this process is important. You're going to use this process in AP Calculus, actually. This exact process for a different topic. But I want you to show you a way to check your answer. Who else are we missing? Inigo and Jeff. That's who it is, Jeff. Okay. So go to Y1. Go to your graph. Notice how important your graph is, by the way. Isn't it crazy how much stuff you can solve by graphing? We've solved equations where we find intersections by graphing. You can solve equations that are systems of equations that aren't necessarily linear by graphing. Here what we're going to do is plug in the original. I mean, it could be the factored form, but I would always plug in the original just in case I made a mistake factoring. So for this one, plug in the original, which I think is at the very top up here. Okay, x to the 4th. And by original, I don't mean the first one up top. It's got to be equal to 0. Okay, so this one right here at the top. X to the 4th minus 7x squared minus 18. Everybody know where x to the 4th is? How do you type x to the 4th in the calculator? Yeah, use the little caret, the little up caret, or the little, I don't know, the like inequality symbol that points up. I don't know how else you would say a caret. Okay, so x caret 4 minus 7x squared minus 18. Hit zoom 6, please. Hit zoom 6. I tell you that because I want your graph to be standardized from -10 to 10. So look at your graph. Who could explain it? Explain the correlation between this number line and your graph. Explain the correlation between the number line you see and your graph. I guarantee you could pick up on it. Take a look at it for a little bit longer. James, you got it?
Is it like the middle part is
Slightly different? What do you mean? Let me see yours.
Mine in the middle, like,
Okay, it is slightly off, but there's more to it than that. Zoom 6. So what that does, you get the number 6. It'll make it 10. Graph it from -10 to 10. If you want to make it a little more obvious, you can hit, because it's not obvious because this graph is very steep. Change your window settings, make your Y min -50 instead. Go ahead and make your Y min -50. Hit window, and now make it more obvious. Hit window, go to Y min, make it -50. What do you got, Sarah? Want to explain it? I saw your hand was up before this.
The two lines pass through.
Good. So right away, the solutions, if this were an equation, were 3 and -3, weren't they? Those are the roots, which are also the x-intercepts. Remember, we've been talking about this all chapter. The solutions to an equation equal to 0 are really the zeros of the function, or the x-intercepts. Now, this is an inequality, though, right? Now, look at this number line. So the -3 and the 3 are where the graph hits the axis, goes below the axis, hits the axis, comes above the axis, right? If I were to literally graph our graph, it would look like this. I don't have a y-axis, so make believe I'm graphing. This is what yours looks like, right? Something like that. Can you explain the correlation between the number line And the graph now? 3 and negative 3 is good. What else? We labeled each region positive or negative, didn't we? Look at the graph. Daniela?
Is it because the part of the graph that's like on the outside represents the function when it's positive, and on the inside it's when it's negative?
That's exactly right. Follow the graph, okay? Follow my point here. If you trace on your graph literally and think about it, you don't have to trace, but just think about it. Here, what are the y values? Aren't they all positive here? The y values are positive, y values are positive, y values are positive. Then what's the y value here? 0, because it's one of our zeros of the function or one of our solutions or critical points. Then the y values are all negative, and this region is negative. Then 0, critical point. Then the y values of the graph are all positive, aren't they? And this region was positive. So if you don't want to figure out these regions, what could you just do? Just graph it and see, is the graph above the x-axis? Whenever the graph is above the x-axis, which it is in this region, label that positive. When the graph is below the x-axis, label this negative. Label this positive. Okay, so your graph is indicative of the number line. It tells you, the number line is giving you the y values. That's all it's doing. The number line is saying, well, the value of the function is positive in the first region, negative in the second region, and positive in the third region. That's the value of the function we have. Well, that's what the graph is. The value of a function is the y value. Yeah?
Are the regions always going to alternate?
Not always. There are some cases that they won't, but for everything we do in this class, they should all alternate, yeah. Okay, but there are examples that will not alternate. Sorry, I saw a hand, or somebody had a hand over here, no? Does it make sense how you can use this to help you? Okay, so use your calculator, please. I can't implore enough that you really get accustomed to using your calculator. That was one thing, and I mentioned this to you guys before, seriously. I think you can do your entire SAT on a calculator. It's kind of sad, to be honest, but you can do like every single problem that way. It's nuts. So you should definitely check. I want to see work, because you're going to have to give me work for this. But if it's multiple choice, if you have a multiple choice question, do it in the calculator. Don't do it by hand. So, for example, on your test tomorrow, I'm telling you now that you will have to factor or find the solutions to an equation as a multiple choice. Don't do it by hand. Just graph it and find the x-intercepts. It's the same exact thing, right? You remember how to find the x-intercepts on the calculator? We did it once earlier in the year. Check it. Let's do it together. Press. We're going to find those 3 and negative 3. See them? So press second, then hit. See where it says trace? Above trace, the word calc is there. So you're choosing the calculate function. Then you're going to choose the number 2, which are the zeros of the function. Now, it's going to say left bound, question mark. Here's what you do. Ready? You look at your graph, and you see your graph crosses the x-axis around what looks like negative 3. But you're not really certain that that's negative 3. So you pick something to the left of that. That's what left bound means. So pick a number to the left of negative 3. Like just to the left of it. What do you pick? Good. So press negative 4, hit enter. Then it says right bound. Now here's the thing, ready? You cannot pick a number that exceeds the next root. So you can't pick something bigger than positive 3. You gotta pick something that's in between. So what you're doing is you're creating a search domain. Your calculator, if you choose negative 4 as the left bound, puts up like a wall right here. Then choose negative 2 as the right bound, please. Press negative 2 or 0, it doesn't matter, but don't pick something bigger than 3. So pick negative 2, it puts up a wall here. That's what the calculator is doing. And then it uses what's called Newton-Raphson method, a method that uses the slope of the lines and then what are called the tangent, the calculus thing you're going to learn about, to get you the root, actually. So then just hit enter. It's going to say guess. Just hit enter once more. And it should tell you negative 3 is one of the roots. Okay, it's going to say x is negative 3 and y is 0. So if you're finding out what the roots are to an equation or the zeros of a function, please just use your calculator. Okay? There's no need to do it any other way. If it's multiple choice I'm talking about. If it says on the test, it's a short answer, you got to show work. Now, how is that different from factors? Be careful with this. What were the factors of this? Go back up. Look back up here, please. Aren't these the factors? And the roots are the opposite of those, aren't they? Aren't the roots the opposite of the factors? So if I give you a graph, this, ready? Watch, take a look. If I gave you this graph, and said the following. This x-intercept is 2. This x-intercept is 5. Tell me the function that represents this graph. Or give me a possible function that represents this graph. Well, you have the roots. To get the function, you need factors, right? What are the factors that give you these roots? When do you get positive 2 and positive 5 as solutions?
X minus 2, X minus.
Yeah. Will's got it down. Take a look. When you have this in the equation, isn't that where you get that answer? So technically, that's when you set the function equal to 0 to do that. So this is indeed the function, or a function of it. You could have any multiplier in the front, right? Watch. And remember yesterday you asked this question? If I put a number here like 7, or 12, or 15, or 3,954, or any number, it doesn't affect the roots. It really doesn't. What it does is it stretches the graph only. But the roots will still be the same. See how the minimum of this graph is located right here? If I were to put a number here, and I made the number, well, first of all, it'd have to be a positive number, because the graph opens upward. See how this graph opens up like that? They both point up. It means that you're going to have a positive leading coefficient. So I could put a number here like 7, or 17, or 317. It doesn't matter. If I were to keep increasing the number, it would just take that minimum and stretch it lower and lower and lower, but it would still cross at the same locations. Okay? So if you're given a graph, or if you have the graph and you want to figure out what the factors are, they're the opposite of the roots. That's all they are. Okay? So if I ask you to factor an expression and you don't want to do the work, find the graph of that expression, find the roots on your calculator, right? And then just switch the signs of the roots to get the factors. Okay, so if the roots are 7, 12, and 13, you have x minus 7, x minus 12, x minus 13 as your 3 factors. And as a result, you would have, something to the 3rd power. Okay, use your calculator to help you. Problem set. Other questions in the problem set? You want to do an example of difference in sum of cubes? It's been a while. I know that was not the easiest thing, but we can definitely do it still. Let's try this. Ready? Let's try y to the 3rd minus 8x to the 6th. Okay, and this problem says factor the following expression completely. Factor the following expression completely. The first thing we need to recognize here is that clearly this is difference of cubes. How do I know that this is indeed difference of cubes? Who could explain why this is difference of cubes? What do you got? What's the reasoning for this being difference of cubes? Nobody knows why this is difference of cubes? Really? What does difference of cubes mean? What does it mean? Well,
y is cubed, and then 8 is the cube of 2. and
good.
X to the 6th is the cube of x squared.
Yes, very good. X to the 6th is the cube of x squared, because x squared cubed is 2 times 3 is 6. If I made this 6 instead of a 6, let's make it a little trickier. Let's make it a 15. What is x to the 15th the cube of? X to the 5th. Okay, so what I do is I start by rewriting this as cubes. Okay, I always start by rewriting it as cubes so that I can identify A as y and B as 2x to the 5th. Again, this is A and this is B. At this point in time, it's just a formula. So if you don't memorize the formula, I don't want to be mean, but to me that's just lazy. Memorize the formula. Okay, it's not a formula you're going to ever be given. You kind of need to know it. Just like you're going to learn the quadratic formula later, which some of you probably know. You need to memorize certain things. It's one of the things you do. So, for example, if I have difference of cubes, what's the formula for that? Because this is a difference here, so I don't need to worry about difference. The positive I can look at later. What's the formula for difference of cubes? I can tell you if you remember. It's keep the first sign and change for the second we went over. Keep and then change. Do we remember what the formula is for difference of cubes? Alex, go for it.
For,
For the top up here, what would I write it as? We'll do the problem itself in a minute, but what does this become? What is the formula you're supposed to remember?
A minus B, A squared plus AB, minus plus B squared.
The n terms, Alex, if you remember, are always positive, okay? The squared, a squared, and b squared are always going to be positive. If I were to switch this sign to a positive right here, this becomes positive, and this becomes negative. That's why I said keep this sign the same, and change this one to be the opposite of this. It's always going to work that way. Now that I know what a and b are, a is y, right here, and b is 2x to the fifth. Literally take 2x to the fifth, plug it in here, plug it in here, and plug it in here. Take y, plug it in here, plug it in here, plug it in here, and go ahead and see what you get. And please just simplify it a little bit. Okay, make it look like it should. So you could leave it like that. Technically, it's still right, but especially if it's multiple choice, it's going to be simplified. I'm going to write it in terms of reducing exponent for the middle term there. Okay, take a look. Make sure you understand the final answer that we end up getting here. Okay, just write it out so that it's in, I guess it's most basic form. Now, what's a note that I told you about in class that you shouldn't recognize?
They can't multiply them?
You can't.
They can't like multiply them?
What do you mean?
They're already like, factored out. You can't factor.
Well, you should not multiply them back out because they're factored, but there's something different. Not about not being able to multiply. What about this trinomial here? Do you know?
Can't simplify it.
Correct. It cannot be factored any further. Okay? This trinomial on the right, y squared plus 2x to the fifth y plus 4x to the 10th, cannot be factored any further. Okay? So this is a problem that you will not get where you're going to solve for the roots. Why can't you find the roots of this? And obviously because it's x and y, I apologize, but to find the roots you would need the basic factors, right? So to find the roots you would set this equal to 0, or the x-intercept, so the 0 is the function. Set it equal to 0 and solve each independently. Well, this trinomial cannot be factored further, so you're never going to get roots from it. The roots from this are going to end up being imaginary or irrational of some sort. You have to use the quadratic formula, which we haven't done yet. You're going to do it. It's easy, but we haven't done it. So I'm telling you now that this will be a problem where it says factor. Okay, so all it's going to say is factor the expression. I'm not going to tell you to use sum of cubes or difference of cubes, but you should recognize that. There's another type. There's the square of sums or the square of differences. Let's go over one of those. So if I have, let's say, 4x squared, leave the middle blank for just a second, plus 9 minus 12x in the middle. You could definitely use AC method, but I will tell you now, if the first and last term are perfect squares, try to use this method that we've gone over in class. Because AC method will get a little bit messy. It's not really difficult with this, to be honest, but if the numbers get bigger, for example, if this number here were like 25, it's going to be really messy. Do 25 times 9 and then go through AC method. So recognize this. Here's your indicating factor for those that have been confused with this. These are perfect squares. That's what you first look for. If they are perfect squares, take their square root each. 4x squared, its square root is what? 2x. The square root of 9 is 3. What's 2x times 3? What's 2x times 3? 6x. Double that. What do you get? And isn't that what the middle term is? Now, obviously, it's negative, right? So what that tells us is this. If you ever get these numbers, multiply them and double it, and you get to the middle term here, you know that this is going to be the factored form, and just simply carry the sign down. And then put a squared term on the outside. If you don't believe me, just go ahead and FOIL it out. Do 2x minus 3, 2x minus 3, and you will get back to 4x squared minus 12x plus 9. I put up a few things. I put up that video I was telling you for the homework. I put up a worksheet for 4-9 for more practice. But you have 4-9 homework tonight to practice anyway. If you have more questions, please look at chapter 4, the test at the end of the chapter. All those problems are really good problems to look at. The test, remember, is from 4-5 to 4-9. Okay? If you still need help, come after school today. I'll be around. Okay, come by.